In exercise 2, what we're doing is building a relatively simple URL shortener. So I think, yeah, I've got it running. Let me go ahead and just restart it. It runs on localhost 8080. And the idea here is that you can put in URLs like, let me see if I have one here. You're going to put in URLs like /YAMLGoDoc, something like that. And it's going to redirect you to another page. So I might be localhost 8080 /YAMLGoDoc. I want 2 slashes there. And this would forward you to some other page. Now there's different reasons why you might want this. One is if you're building a URL shortener. Another reason is maybe you want to be able to redirect or rewrite all your links so they all start with the same domain. So getting started with this exercise, the first thing I want to note is that there are a couple source files you're going to look at. The first is handler.go. So this is the stubbed out package that we're creating. So in this exercise, we're not creating an execute, like we are going to have an executable we can run to test it, but we're creating this as a package that provides 2 functions to the end user, this map handler function and this YAML handler function. Now we're not exporting anything else. So make sure when you're creating types and things like that, that you're using lowercase letters for the start of the function names or for the types, things like that. We shouldn't need to be exporting any other types or anything like that. It should just offer these 2 functions that return handlers, and that's it. The next thing is inside of the main folder, I have a main.go file. And this file is a main function that sets up a default mux. We'll then build a map handler, and then we'll build a YAML handler, and it'll run those. It'll run them all on localhost 8080. So whenever you run these, one thing to keep in mind is that it's kind of in a fallback order of first it'll check for the YAML paths, then it'll check for the map paths, and then it'll fall back to the default mux. So that's the order that it sort of goes through things. So we're actually chaining these fallbacks a little bit as we go, which is just a nice cool thing that you can do with interface chaining and that sort of stuff. So you're going to kind of see that, even though we won't talk too much about it, that's what's happening. So once you've looked at main.go and the handler.go, you should have an idea of what to expect. I do have a little bit of notes here that talk about you're going to want the YAML, you're going to want a YAML package. I linked to one so you can use it and you can go get it. There isn't one in the standard library, at least not at the time of me recording this, there wasn't. And it's still like a fairly common encoding scheme, so I wanted to just go over it. We will be looking at JSON and others throughout this course. I'm trying to rotate through them as we go. And I also provide a little bit of info here as to how your YAML handler might turn out. I do this because it might be tempting to write that entire handler from scratch, but if you instead convert your YAML data into the map format that your map handler expects, the upside of that is that when it comes time to testing and things like that, you don't have to worry about that portion of the code because you've already written a test for the map handler more than likely. And if you're using the exact same handler, the only thing you really have to test is that once you parse the YAML that you can spit it out in that map format. So it really helps simplify tests and maintainability and that sort of thing so that if the functionality of your package changes, you only need to change it in one place. There are other upsides. For example, looking up a key in a map is going to be pretty much constant time, whereas looking up a value, seeing if a path exists in a slice is going to be order of n, where you have to iterate through the entire slice potentially. Now you could sort it. There are other ways to sort of speed that up, but it's just something to keep in mind. Finally, there are some bonus parts. This is one of the exercises that I definitely suggest looking into them a little bit. So one of them is to just change it so that, one of us to make your main.go accept the YAML file from a flag. So that's kind of taking from the last exercise using flags again and just reinforcing them. The second bonus option is to add a JSON handler. I mention this because it's really nice to see what code that you wrote for your YAML handler can be reused if you make a JSON handler, or which code from your map handler could be reused if you make a JSON handler. And to really just see that there are a lot of times where you can reuse things as long as you get it to a common format first, and it can really simplify your code. The third part is building a handler that reads from a database. So this one is, it's added in here because this is probably what you're going to do if you're actually going to production with something. Now, there are cases where maybe you just have a JSON file and you expect an engineer to redeploy every time the paths that you're using change. And that's fine, especially if it's a really small thing or small operation, you don't expect other people to be touching it. But a lot of the time what will happen is you'll be using something like a Bolt DB or SQL, something like that. And you're going to want to be able to read from the database and go that way. So that's another thing that I'd look into. And I'd actually suggest trying BoltDB. I say that because BoltDB doesn't require you to install anything on the server. It's a completely contained Go package that you can install and use. And it's for this purpose, it's actually going to work really well. Most of the time with the URL shortener, you're just reading values. You're not writing a lot. And BoltDB is really good at a lot of reads, but just a smaller amount of writes. To start with exercise 2, what we're going to look at first is just the main function that's going to be using the package that we're going to be building. So we're going to be building this URL short package, which is going to implement this map handler and this YAML handler. And there's a lot of comments here. You should definitely check that out if you haven't already. But before we jump into that code, it's a good idea to look at how that code is going to be used to make sure you really understand what's going on. So looking over here, we're going to look first at the map handler, and we'll see that we've got the URL short-go doc, which we want to map to this go doc /github.com/Gophercises/URL short. And we've got another one. So basically these are giving us paths, and they map to some other URL. It might be longer, might be shorter, but that's the idea here. And then if we come down here to the YAML version, which we're not going to be building right away, but you'll see that it's very similar, except the format we're getting is a little bit different. So in the YAML one, we aren't getting a key and then a value. We're just getting in YAML, this ends up being an array. So you've got the first part of the array is the key of path and then the value, and then the key of URL and then a value. So if you were looking at this in JSON, this YAML would actually be something like, I think it would be something like this, where it's an array and each one has a path that has some value. And then it also has a key of URL, which has some HTTPS, semicolon, // and this goes on. And we'd have a bunch of these. So it's going to look something like this. Now, we're not using JSON, but that's roughly what it's going to look like. So looking at this, one of the things that's interesting is that it's not the same format as up here. So using the map handler right out of the box is not going to be easy with the YAML handler. But if we could convert this into the same format as what the map handler expects, whenever we implement that part, we could actually use the exact same handler. So let's start by looking at the map handler, now that we see what we're doing. And in here, we want to return an HTTP handler func that is going to, essentially we want it to fall back to this fallback handler if there's no paths that match this perfectly. But if there are, we want to go ahead and use it. So to start, what we're going to do is we're just going to go ahead and replace this return nil stuff. And we're just going to have it return a function that takes in first an HTTP response writer. And the second argument is an HTTP.request. So this all stems from the fact that an HTTP.handler func, if we come over here and search this, this is going to be a type that really is just a, if we go to handler func, it's a type that's really just a function. So it's a function that takes in a response writer and a request pointer. So that's all we're doing here is we're just returning that type of function. Now we don't have to actually cast it, so we don't have to, or convert it. We don't have to do HTTP.handler func and convert this because this will already happen for us since we're returning the handler func type, and it's already pretty implicit as to that's what we want to do. So in this case, we don't have to worry about that. What we're going to do here is we're going to say if if we can match a path, and I'm going to put this if as part of the comment. So if we can match a path, we want to redirect to it. Then we're going to say else. Otherwise, we're going to call fallback with W and R, or actually it's fallback.serve HTTP because it's an HTTP handler, which is an interface. It's not an actual handler func. So that's pretty much all we're doing here. We're just going to say if we can match a path, which I can't type today apparently. Otherwise, we're going to use that fallback. So we've already got about half of our code written. Now all we have to do is basically say, how do we get the path from the incoming request? And how do we check to see if it's in our paths to URLs map? So the first thing is we're going to say the path is equal to r.url.path. So this is just taking the URL from the request. So r is the request. It's saying, give me the URL from that request, and then just give me the path part of that, because that's all I care about. Now, we're not going to do any trimming or anything like that. We're not going to try to clean this up or do any parsing or whatever, because what we're really looking for here in this relatively simple handler is not to do that type of logic, but to just say, if this path matches exactly to something in my map, I'm going to go ahead and forward it. So once we have that, what we're going to do is we're going to say, if we have a destination inside of our paths to URLs, and we're going to use the path as the key. So what this second variable, the OK, is doing is it's saying, if you find a key, or if you find this key in the map, this OK will be true. Otherwise, it's going to be false. So you don't get an error here, but instead you just end up getting a true false for the second argument. This destination argument is going to be that actual value. So assuming we do find something, this will have a value. So what we're going to do from here is we're going to say that if this is OK, so if we found a match, we're going to http.redirect, and we're going to use W as the response writer, R as the request. The URL string is going to be the destination. So this is going to be the URL that we found inside of this map. And then the code is going to be http.statusFound. So relatively simple. The status found is just a simple status code that's saying that we found the page they're looking for. And then we're going to return, because we don't want the rest of our code to end up running, so we're going to make sure our handler function returns at this point. So we can delete this part, and this is actually everything we need for the map handler. It's more straightforward than you'd expect because there's not a lot to do here. It's mostly just getting the path, checking for it in the map, and redirecting. So now that we have that working, let's go to our main.go, and we're just going to test this. So to test it, what I'm going to do is I'm going to take this and make map handler, and then I'm just going to comment all of this out. So now I'm going to go run, I think it's not sure where I have this. Go run main/main.go. And you'll see that it starts a server on 8080. So let's go to localhost 8080, and it says hello world. So let's go back to our code and see what's going on here. Our default mux that we create, if you scroll down here, whenever it uses slash, which means map anything. That's just how the serve mux in the standard library works. If it ends in a trailing slash, it basically is like a path prefix type thing. And in this case, it's going to use this hello handler, which is prints hello world. So that's what happens when we just hit the home page. But if we try one of these, things, we're going to see what happens with it. So let's try the YAML go doc. So if we add that, you'll see that this ends up matching. And because it matches, our web server redirects us to this path here. Now you can also see that if we go to localhost 8080 and then put an invalid path, that again, this is going to go to that hello world thing because we set this up so this is sort of like a path prefix. But if you had a different router here that maybe only had specific routes, that router might be able to handle a page not found type thing or something like that. So that is always an option whenever you're working on something like this. So we're going to take this and we're going to change it back to YAML handler, and I'm going to uncomment all of this code back out. And what we're going to focus on now is we're going to try to make this YAML handler part work. And to do this, you might be tempted to parse the YAML and then create a separate handler. I'm actually going to try to use this map handler all over again. One, because I know my map handler is actually pretty efficient. Because we're looking up the keys inside the map, and that should be relatively constant time to do that. Whereas if we iterate through this array, it could eventually take as long as maybe there's 20 different things in there, and we got to look at all 20 to see if there's a match. So we know that's probably not the most optimal way to do this. Going back to our code here, this is where we're trying to implement this part. And to do this, we need to use a YAML package first. So we need to parse the YAML. And once we parsed it, we then need to turn it into a map and use the map handler. So our code is going to look roughly like this. Step 1, parse the YAML somehow. Step 2 is going to be convert YAML array into map. Then step 3 is we're going to have some map. So let's say m : equals, let's just call it paths to URLs. : equals map. It's going to be a string to strings. It's going to be made at some point. Now I'm just stubbing this out right now, But step 3 is going to be return a map handler using the map. So we're going to do something like return map handler, paths to URLs, and then we're going to pass in nil as the error, because at this point we know we're not going to have an error. And let's see. Oh, we need a fallback handler. So that's what we're going to be doing here for step 3. So step 3 is actually really easy. Once we have everything built, step 3 is just calling some code we've already written. And if we were writing tests, it's code that we probably already tested. So all we really need to do is look at steps 1 and 2 and see how to write that code and how to test it. So we'll first look at parsing the YAML. And to do this, we're going to come back to, we eventually had this open. I'm going to go ahead and grab it from here. We're going to be using this YAML v2 package. In the YAML v2 package, we're first going to go ahead and grab this. So opening up the terminal, go get -u. I'm doing -u to make sure it updates, just so I know I have the same version everybody else is using. And we've got this YAML package, and we're going to look at how to unmarshal some data. So marshaling is when you're taking data and turning it into YAML. Unmarshaling is when you're taking YAML and taking it out into some other format. Well, looking at this, there's an unmarshaler, which it looks like it just takes in a function of some sort. So I don't know if that's what we're going to want. But if we look up here at the unmarshal function, you'll see that it takes in a byte slice and whatever interface you want to write that data to, and it'll return an error if there was an error. Otherwise, it's going to convert the data over. Looking through the docs, you'll see that this is just using struct tags to figure out how to deal with it. So we can actually very quickly just set up a type and use that. So coming down to our handler, we're going to say type, let's call this path URL. Inside of this, we're going to have a path field, which is a string, and I'm actually going to wait to do that, the tags. Then we're going to have a URL, which is a string. And both of these are going to be used to parse the URL and the path fields coming in from the YAML. So they're used to parse these two pieces here. So what we're going to do here is we're going to highlight all this. And since I'm using Atom, you might have to type this manually or do whatever you do with your editor. But we can do something like go add tags, and we can make this YAML. And at this point, I have to press the add button to make this work. Hit submit, and you'll see that I now have the YAML tag path and the YAML tag URL. So we have this path URL type. So we're going to say, for step 1, we're going to say pu : let's just say var pu path URL. Except that's wrong. So we're going to say path URLs, and we want this to be path URLs, it's going to be a slice of path URLs. So we're going to go ahead and declare this variable, and then we're going to use the YAML.unmarshal, and I think it's 1L. So we want to pass in the YAML bytes, because if we look back here, this unmarshal, the first thing is the bytes. The second thing is where we want that to be written to. So in this case, we're going to pass in path URLs, and then we want to capture the error. Then we're going to say if the error is not equal to nil, we're going to return nil, error. And let's see. Oh, I know what's going on here. This is named YAML, which is not what we want. So let's do YAML bytes. And then let's see what's going on up here. Oh, we need to change this part. So what was happening here was I had an argument to my function call named YAML, which was sort of colliding with the name of the package we were using. And I could have changed the name of the package we're using in here, but in this case, I felt it was better to change the argument that I'm having come in. So these two things got changed to YAML bytes. So if everything went well, at this point, we should have the URL paths. So that's all there. The next thing we want to do, these path URLs. So we should have a slice of those. So the next thing we want to do is convert this array of YAML paths and URLs into a map. So I'm just going to say, or start with a map. So we already have it here, copy it, bring it up here. And I'm going to actually change this to be make. And we'll just make it this way. And then we're going to go ahead and iterate over path. We'll say path, let's say pu : range, path URLs. So in this case, we don't need the index of every path URL, but we do want the entire object that we're going to get, the path URL object for each one in the map. Or rather, we don't need, that's the index. So what we're going to do here is we're going to say paths to URLs, pu.path equals pu.key. Or I think it's URL. Yeah, that's what it is. I don't know why I was saying key there. So what we're doing here, we are first making our map. It's going to be a map of strings pointing to strings. And then we're going to iterate over the path URLs we have. So this slice of path URLs. And for each one, we're going to add it to our map where the key is going to be the path and the value for each key is going to be that URL. So it's basically turning into the exact same format that we're expecting up here in our map handler. So coming back down here, once we've created this whole path URLs thing, our step 3 is already written for us. It uses that, creates a map handler, and returns it. So at this point, this code should probably work for us. We can go ahead and try it by running this main.go. So we're going to go run main/main.go, and I know what's going on here, but it's annoying. Somehow, whenever I commented this out, it changed some characters or something. So if I uncomment it out, it seems to fix it. I'm not really sure what was going on there, so I'm not going to worry about it right now. So going back to our code here, what I want to do is I want to get one of these paths that are, I'm going to go ahead and grab this URL short one, and I want to go ahead and just slap it in here and see if this redirect works. So it does look like that this redirect is working from the YAML file as well. So let's make sure one of the ones from our paths up here are working, because if you look at the code in main.go, it creates a map handler, which falls back to our default mux. But then whenever we create the YAML handler, its fallback is the map handler. So we've kind of got this chain where both of our handlers are ended up being used depending on which one's mapped to things. So if we grab the YAML version or link here, we can do the same thing, localhost 8080, and this works as well. So well, I guess we can just stay here if you really want. Once we've got this working, you'll see here that I talk about how when you're building the YAML handler, it's very possible that you could end up building this a little bit, I'm going to say cleaner, in the sense that we could take a lot of this code out, and just put it into a function, and this code really just becomes parse the YAML, turn it into a map, call the map handler. Just 3 simple steps. So all 3 of these could be candidates for small, simple functions that you could unit test. For instance, we could write a func parse YAML. It takes in the data, which is the bytes, and it's going to return either a path URL or a slice of path URLs or an error. So inside of here, what it's really returning is this part here. So we can grab all this and say return path URLs, nil. And we need to change this bit to be that. So you can see that really we just copied code we had, moved it into this function, but we've isolated it, so if we really wanted to test this individually, we could. Now coming up here, what we're going to do is say path URLs, equals parse YAML. We'll pass in the YAML bytes. And I think we need to capture, there's an error here. And then we can just delete those 2 lines. We still want to check for an error and you decide what to return based on that. You don't necessarily have to return. So you'll see me do this a lot in code. I will put if error is equal to nil or not equal to nil, return nil comma error. And there might be a case where I could just return like x comma error. I don't do that most of the time because there are sometimes sloppy developers who will check to see if the first value is not nil, and if it's not, they'll use it. They'll just ignore the error part entirely. So I like to make sure if I can make the first part nil or an empty value or whatever, I do that every time, even if there is an error, just to sort of prevent that. Now the second part, maybe we want to turn this into a method or a function. So I'm just going to go ahead and show you how you do that as well. So we could have func build map, and this might take in path URLs, which is going to be a slice of path URL. And it's going to return a map of strings and strings, or strings that point to strings. And for this, we're going to go ahead and just copy all this, paste it all in here, and return path URLs. Paths to URLs, that's what it is. So that's all we have to do for this build map part, and we can actually just take this code here and actually make this build map path URLs. So now we can delete these comments. And we've got two smaller functions that would be much easier to test if we wanted to. By using this build map function, another benefit to it is that instead of needing to rewrite this whole part, if we say had a JSON handler, we can instead end up building a JSON handler that as long as the data comes in, maybe it comes in a map format, so we don't need to do much for it, but it might come in a format that's an array of paths and URLs like our YAML is, and in which case this part of the code would change for a JSON handler. But once we have the data parsed in this path URLs type slice, slice of path URLs, we could easily use this build map function again to create that part of it. So this doesn't actually care. It has no care in the world about whether it was YAML data, JSON data, or something else. All it cares about is if you give it a slice of path URLs, it will turn it into a map for us. So that's also a nice handy thing to keep in mind, that when you break these up, you can make them a little bit more reusable.